Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is Free Energy Friday. It is March 20th, 2026. Welcome to the show. Also with us tonight, we have Philip. He's in LA right now, and we have Lulu in Texas. And we have Mr. Benefactor. He's also with us. He's in Michigan, right? You're in Michigan?
Yep.
Yep. You're not too far from me. You're just across the river.
Yeah, just across the pond.
I heard there was a snowstorm in Canada recently.
Well, we had a bit of snow, but it was like Ottawa and Montreal got hit with it. East. And there was a lot of avalanche warnings out in BC. Apparently it was getting quite dangerous up on the slopes there. So, yeah, today's officially the first day of spring. So we're headed into hopefully some better weather. I'm going to be getting into the lab and start working on the renegade device. And I still got the battery thing going on. I took off last week because my wife had an operation, so she's doing better. And we decided we're going to do a show tonight and carry on with all the science that we work on. Yeah, and the other thing, I totally forgot next week's my birthday too, so another year. Oh my God.
Happy birthday.
Yeah, Wednesday. Wednesday is my birthday.
My marine business colleague, he's 44 years old or 45, and he runs 45 miles, as much as miles for his birthday each year. 45 miles, man, that's like the equivalent of 10 hockey games.
Yes, yeah. 10 hockey games.
What is it going to take him 2 days? We'll take him 2 days to run that.
Takes him a
day. All right.
Yeah. So, anyways, yeah, I guess we'll get into the updates. Philip, I guess we usually start with you, so I guess we'll start with you and just kind of do a round table here.
Yeah, obviously I didn't have a chance to experiment, but in my head, yes, and I figured out a way to optimize the MHD vortex of liquid gallium. I know how to optimize its efficiency. I'm not going to say how because I want to get funded by DARPA. So yeah, I'm pretty happy about that. So it's a good timing too because I did not submit to DARPA yet. So I'm gonna make my corrections to my presentation. I'm gonna send them, and I'm looking forward to that. And
isn't DARPA in Massachusetts?
No, it's in Virginia.
Oh, they're in Virginia.
Yeah. All the deep state people are in Virginia.
All the deep state. There's a lot of shout out to Bernie.
And yeah, I went to the NVIDIA GTC conference in San Jose yesterday. I didn't make $1 million, but I made a lot of important point of contacts. So I'm gonna follow up next week on that. Um, I discovered there was a bug in my software 2 hours before I went to the conference. I fixed it, but um, I'm gonna clean it up correctly this weekend. So
That's always the case. I don't know how
No.
many times I've had to give a presentation on something, and then at the last minute, something screws up.
Never fails. What do they call that? Murphy's Law.
Murphy's Law, yeah.
the Murphy's Law is it's whatever you don't want to happen, it's gonna happen at the worst time.
Yeah, exactly.
Have you ever tried selling a car and then you want to sell it, it stops working? Yeah.
Yeah,
Oh, the funniest is my grandfather, who recently passed away. He was selling his Rolls Royce. He was trying to sell this thing for a long time. And my brother, he's got Williams syndrome. So sometimes he says stuff, he blurts it out. And my grandfather's trying to sell this Rolls Royce. And and he's like this close to getting the guy to like be interested in buying it. And then all of a sudden at the end of the their introduction to the car or whatever, my brother blurts out, "Oh, and it knocks."
Perfect.
He said the engine knocks.
The engine knocks. Oh my God. That's hilarious.
Oh yeah,
That's
it was a funny story.
It knocks.
But
The
sorry, I
brakes
didn't mean to
don't work.
interrupt you, Phil. Go ahead.
So yeah, no, but seriously, I'm really happy about the optimization for the MAG Vortex, and we're gonna have we should have like it should be 1,000 times more efficient with my.
Can you give us a little bit of information? Just a little bit?
No, or else I'm gonna have to kill myself.
That's fair enough. You want to keep it for privatization.
Yeah, you gotta have something that you keep as yours, right?
Yeah,
it's
that's
just-
true. That's true.
I'm still in the APEC chat, and I share a lot of things publicly, and after some time they say, oh, they keep dragging you down. They say, oh, what you do is not good, blah blah blah. And
You know what? I actually watched APEC last weekend. I was like incredibly bored, and I started listening to the whole thing, and I was bored like within the first 10 minutes. Like,
yeah, I didn't watch it at all.
seriously,
That's their goal. It's to get you bored so you're not interested in the subject matter.
it was total nonsense. 98% of the stuff they were talking about. It's like I didn't learn anything here. You know what I mean? Like,
We had me and somebody else in chat who had contacted Jeremy, and we were kind of like, asking, as Jeremy was in chat, like, hey, why haven't you responded to our email? We have some interesting stuff going on. He never said anything.
I haven't seen him online in a while now. Jeremy Reese, no, haven't seen him online.
Well,
at all.
whoever was representing his channel was in the chat, like the APEC channel.
Yeah,
So
but
they were
actually seeing Jeremy Reese on the screen, I haven't seen him.
No, I haven't seen him I don't think he was on the screen. No, just in the chat. Somebody was in the chat representing the channel. Maybe it wasn't him.
Yeah.
So we had contacted him, and we never got a response.
Yeah, exactly. That's why I haven't really stuck around the Apex scene, because honestly, it really doesn't do anything for me. They're just talking all theoretical science, and it's like, well, let's see something. Let's see.
Yeah, well,
Some kind of practical application.
They talk theoretical. They did all the experiments. Initially, it worked, and they just sidelined me. It's like, what the hell, I mean,
Yeah, they did sideline you.
Yeah, it's like, what's wrong with them, And do they want to find something that works or not?
Yeah, dude, Phil has a demonstratable tractor beam.
Yeah,
we've all seen the Crookes radiometer, you know, like where light can, you know, push light objects. But we've never seen it attract anything, and until you've seen Phil's demonstration, that was insane.
Yeah.
Oh,
But you know, the good thing about that being sidelined is I'm not going to make everything public, so it forces me not to make everything public.
Yeah,
I can make money off the grants and stuff like that, so that's good.
Yeah, like some stuff you have to keep to yourself.
Yeah.
Like my solid state electrolyte, I've only told a very small selected few people what I'm doing.
So I should thank Tim. I should thank Tim actually for sidelining me. You know, I should thank him.
We'll give you a second thought on to keeping some of it too close to your chest.
Yeah.
I mean, Elijah, you know, we've all been there. Like, should I release some of this or should I keep it? And no, Mike is right though. You know, like for your own security, financial or whatever.
Exactly.
What is that, Mike?
Here, hold on. Let me take off my background here. So I'm going to go to the next level here. Okay. So what I bought is a sealer, impulse sealer. So now I'm going to seal up all my cells. So they're going to be protected, you know, not be exposed to the elements. So I'm going to vacuum seal them and seal them with this, what do they call it? Impulse sealer. So I got
there's a Toby in the big chat. He released his theory, his own theory. Maybe I can invite him at some point. I'm gonna ask because he's from Montreal actually. He speaks English, but he lives in Montreal, so that might be somebody interesting.
Yeah. What does he specialize in?
Well, he has his theory, but it's all experimental, based on experimental stuff that was already done. So it's more like an engineering thing. So you guys are gonna like it. It's not gonna be just equations, theoretical shit.
Yeah. Oh, something I found out this week. Right, I was looking up, reactive metals. So I'm thinking, okay, there are some metals where they try to mix stuff with, so you're making different alloys. So aluminum, certain series of aluminum, usually it's the 5000 series aluminums that has magnesium in it, up to 6% per weight. So how do you test it? How do you test metal to see if it's reactive? Very simple. Vinegar. Put a drop of vinegar on the metal. If it starts to bubble and fizz, it's got magnesium in it. That's how you can tell. So if you have a piece of metal and you want to know if it's reactive or not, just drop a drop of vinegar on it. And
that's
if it starts to bubble. Mm-hmm. So, like I got this from work. I had some scrap. So this one's 5052 aluminum. So if I drop a bit of vinegar on this, it will start to fizz. So it's got
without having
6%.
without having to abrade the surface, right? No abrasion to the surface for it to fizz.
Yeah, just just a simple vinegar because it's a mild acid, right? But if there's magnesium in it, which 5052 does, it should start to fizz. So if you have scrap metal around, you want to know if it's got magnesium and you could use it for making a battery, just put a little vinegar on it. You'll find out right away. So just a little tip. So I'm going to experiment with this.
You could use that.
I want to see. Sorry, go ahead, Elijah.
You could use that as a low energy nuclear reactor fuel. It's been done before, and I'm sure you could do it too.
Yeah, exactly. So this one's 5052. Any of the 5000 series aluminums, usually they're used for marine, like boats and stuff like that. And that's the type of aluminum, if you want to use aluminum as your anode. So Yeah, I'm going to experiment with it and see what I get. And oh yeah, and the other thing I want to show real quick is my diodes I made, my self-powered diodes, my Hutchison diodes. Look how small they are, and they put out power continuous. Like I built these last Saturday, so I just want to really quick take a reading on it and see what I have. So these ones have magnesium in it. There's no liquids at all in it. Zero liquid. It's all solid state.
So you can use them as a diode and as a battery.
Yeah, like put it into your circuit. Yeah.
Yeah, that's cool. I gotta get with you on how to make one of those.
So 1.46 volts, and they've been sitting a week doing nothing. Let's try another one.
See, that's exactly what I need because there's a drop in voltage with the diodes that I'm using slightly, and if we can boost that.
Like these ones will fluctuate. It depends on how much carbon you put in the diode itself. But you can use it in a simple circuit, like if you're powering, say, a clock or something like small device, right? You know, these just put these right in line with it.
How does it take high speed pulses very well, or is it not really made for that?
Right now I'm just putting it through its testing. Like I got one here right now. It's putting out 1.81 volts, and it's been sitting a week.
Yeah, that's great. And if you can stack them, that's even better.
Well, I made about 10 of them, and I was able to get 450 milliamps.
Wow.
Almost a half an amp.
But I'm saying, like, you know, those diodes, if you're worried, like I am, about that drop off in voltage, you know, like that's a brilliant solution because it's providing its own voltage.
Well, you put enough of these, Ben, and you could have an infinite running Joule Thief circuit.
That's what I'm saying. Like, I really want to try that with the Joule Thief. That would be really interesting.
So what you do is you buy nylon, I believe this is nylon tubing. You buy it at your hardware store, you know, nylon tubing, and you cut out about 1.5 inches of it, and then you buy the inner diameter of this hose is 80 thou. 0.8 thou. So, and you cut 1 inch off, and then you put one screw that's press fit, push it all the way in, and then you put your electrolyte material and carbon and a little piece of magnesium in there, and ram it together, push it really hard together, and then boom, you're done. You got instant power. You know, this won't power a car. You know?
No, but it's gonna supplement the drop in voltage that we get with the diode on the Joule Thief. You know, we get a little bit of loss on the diode, and that's what I've kind of been figuring out a workaround, and that's brilliant if it can handle the high speed pulses.
Great.
But that's cool. That's cool. I like that. That's very simple. You said that's Hutchison based design? Yeah.
Well, back in the, I would say early 70s. The first time I talked to Hutchison was about 2006. I used to do my podcast back then, conspiracy podcast, and we were able to get Hutchison on. Actually, we had him on, I believe, 2 times, and I was totally captivated with this guy. Totally unbelievable. So he was saying in the early 70s he had access to the old radar countermeasures from Navy battleships. So he got in the control box, and he found these little diodes in there. So he's looking at them and go, "Oh, these are cool." And he just decided he was going to do a ohms test reading, and then he flipped it to the voltage. And all of a sudden, boom, he had 0.45 volts in this tiny little diode, like really, really small diode, almost like a germanium diode. It was putting out voltage. And he goes, "Well, that's kind of weird. I never heard of a diode having power."
Yeah.
Because a diode's basically just a one-way valve, right?
Right.
In theory, that's what it's supposed to do. So we start doing experiments with it. And he found out if he took the diode and walked into an area where there was a lot of light, the voltage increased. And also, when he went in the dark, the
So it
voltage
was photovoltaic.
it
Is that
had
what
a
you call it?
it had a photovoltaic. Okay, Elijah, you're shaking your head.
Yeah, he's shaking his head. He's got some information.
So it's not photovoltaic because it's not the Bethe-Hilter process. But what is going on is it's an NP junction, and it is optically coupled to the environment. So the charges, they will separate and they can smash back together depending on if it's forward or reverse biased, right? And so when
Right.
you have an oscillating circuit, the charges, they go out and back in and out and back in like that. And basically that is like altermagnetism. So when you have two cross E fields,
Right.
you can generate an altermagnetic field. So instead of ferromagnetics, where everything aligns like vertically, all polarized together, you get
Right.
polarization only in the diagonal rows in the crystal lattice structure, both ways, right? So like 90 degrees from each other. So what happens is the upspin electrons aggregate with the positive sign of the light, and the downspin of the electrons aggregate with the negative sign of the light of the dielectric portion of the optical switching. If you were to like look at the wave in a transverse manner, right? And that's Dr. Bratton's work on semiconductors. And so scientists recently figured out that if you take a tunnel diode, because um, basically it's frequency, it's not just tunneling, but it appears to be tunneling with a high frequency voltage and a small band gap. What you can do is you can actually not only have the diode being entangled to the light of the environment, but it actually starts acting like a laser out of the little gap that is like it's tunneling through. And
Really?
so
So it's focused energy.
both.
It's focusing.
Yeah,
the
it's
energy.
focused energy from charge oscillating, right? Because any charge that's oscillating, it'll oscillate in the presence of a magnetic field, and likewise, it's acting like an LC circuit at that point, right?
So what you're saying is that it's able to interact with the light instead of it just being like a chemical process. Like the magnetic field
Right.
is able to interact with the light wave itself.
It's making it oscillate. The light's making it oscillate, right?
Right. So it's not just phase conjugate waves that's creating the Bethe-Hilter process, like in a transistor, because you have an NPN or PNP that creates a phase conjugation of bilateral symmetry, just like a solar panel. So that'd be your photovoltaics, right? But what's happening here, because it's an NP junction, you have asymmetry, and you do have the charges kind of positive and negative coming out and back together, similar to a phase conjugate wave, but with opposite charges, right? So the positive and the negative, they want to stick together. And then when they're pulled apart, you know, there's basically an asymmetry of force and the time domain hysteresis. Like you're basically changing the velocity factor and playing with the time domain transduction, because and that works best in longer wavelengths like radio, but with these faster switching diodes, it's spatially very energetically dense. And if you could figure out how to have that same principle operate in the radio wavelength, you would be making that thing output way more energy.
So does the size of the diode have anything to do with that process? Like, does it need to be really small, or can it be kind of big?
Well, it depends on what you want. If you want focused energy spatially, versus if you want to get a lot of energy out of it, versus do you want to warp space-time for like gravity control, right? It's like that depends on what you're going for. So if you're going for more energy, you would try to basically have so delta E times delta T equals constant H. So delta E and delta T are inversely proportional. And so if you want more energy, you would have to have like a smaller delta E, you would have to have a larger delta T, right? So what that means is you would overall with the wavelengths of light, you get more energy with the longer wavelengths, even though per packet of photon, you have more energy spatially with high frequency light. So if you figure out the velocity factor aspect of the switching of your junctions, what can happen is you can get phase alignment of the orbitals between the NP junction at that interface. And what happens is you get phase alignment between the orbital levels. So it becomes a broadband amplifier of the environment. Because instead of just a quantization level here and here and here and here, they all smear together and now can tap every frequency within.
Yeah. So, anyways, so Hutchison was experimenting with these little diodes for years. But the funny thing is, he never tried to attempt to um, recreate these diodes, like try to figure out what was inside of them. I think maybe it was the crystal cells he was working on that kind of sparked the idea of these diodes putting out power that he could take certain minerals, put it together, bake them, and then hit it with a high voltage as it's curing and create these crystal power cells that he was working on. But like the stuff I'm working on right now is putting out way more power than what Hutchison was working on. So, yeah, that's what I've been working on the last little while since I haven't been able to get into the lab. I'm just doing a lot of this stuff at home. Ben, sorry, Philip, did you have anything else or?
No, I mean, I'll let you know how it goes next week for my submissions. And oh yeah, I figured another way to, but it's kind of public, you know. A lot of it is public. It's about quantum tunneling. Um,
Yeah.
it's about using destructive interference. So you could technically send a message um, privately and then decrypt it. But I still need to figure out how to restore the EM wave. So I know the EM wave can be speeded up by converting the EM energy into kinetic energy back and forth.
Right.
And but I still need to figure out how to restore the EM wave that has a destructive interference into a normal EM wave. But it could be used for encrypted messages faster than the speed of light. So, so
That'd be like that would be getting in the realm of what Tesla was doing with the longitudinal waves.
yeah,
Because
Right, you could use that for communication in space, long distance.
oh, for sure, yeah. Like
Yeah.
using anything magnetic, you've limited yourself big time. As soon as you start using the scalar wave that Tesla was working with, you could have an instantaneous propagation between the Earth and Mars with no delay by using scalar, longitudinal waves.
See
A lot of
go ahead.
Go ahead, Lou.
No, I
No,
was
go ahead.
thinking, I talked about this in the past that they can have communication with the Voyagers using this method way
Yeah,
faster than what they're currently, because now it takes
yeah.
them like 22 hours for
Well,
each.
you know what? It is what it is. It launched, I believe, in 1977. So
Yeah.
we're talking, almost 50-year-old technology here. The stuff we have now, they could implement the stuff and be way faster, way way faster. It's just a matter of making it and actually working with it. There's been some stories that they were working on this faster than light communication down in Antarctica in one of the laboratories down there. they had these things called DOMs. They're like about basketball size, and they strategically lay them out in the ice in Antarctica. And I've seen an interview with a guy. He was, I guess, a firefighter that worked in that facility for quite a while, and he had access to probably every single area of that base down in Antarctica. And they were doing earthquake experiments using these DOMs, using longitudinal waves. And they had an accident. They actually were disclosing that it was they had an earthquake in Christchurch, New Zealand, that was caused by them by accident. It was that was what they intended to do, but it got focused on that area of the world and caused a major earthquake. So he goes, the technologies they have down there are way far behind, you know, than what we see here in regular civilization. They're dealing with some stuff out there that, you're getting into the realm of playing almost God. If you could start triggering earthquakes and, actually designating, okay, we're going to make China have an earthquake or Iran have an earthquake, and they could choose areas and, have the equipment to actually pull this off. That's a dangerous weapon. But it always seems like when these great inventions get into the hands of the military, all they want to use it for is destruction. But some stuff can actually be modified and actually used for something good. So why don't they use this technology for like transmitting communications at very very long distances? So you could have real time video of Mars. Put it on a rover and have a rover. The guy could be with controlling a drone, right? It's real time. Well, they have the capability of doing that with a robot on Mars in real time, because right now, as we know, it takes I believe it's 20 minutes. So they have to send the signal out. It takes 20 minutes to get to Mars, hits the rover, interpolates what it has to do, and then sends a message back to Earth, which takes another 20 minutes. Well, if they have the technology to make it instantaneous, why aren't they using it?
2 words: manufactured obsolescence. So there's no profit in giving a solution that's permanent, like free energy. So they'd rather let the public domain spend billions of dollars trying to solve the solution that they already have, rather than give the solution to us, because it's not profitable. They want to keep it to themselves. Either that, or they don't want the military and their private friends and their friends in the private sector, the military industrial complex, the defense contractors and all that. They probably don't want their enemies to have certain technologies too. But like they'd rather see us waste away our resources and destroy our environment before they give us any of those secrets.
Yeah, that's because the big banks, they want us to be in debt because it's free money for them.
It's control.
Very simple.
And
Controlling
then you
us
have
being in debt.
and then you have our group. you know,
Yeah.
That is shadow banned every week by YouTube.
Yeah, my channel's been blacklisted so hard. Like, I should be over 5,000 subscribers. I'm at 3,700 for the last 6 months. Like,
But you
what the heck?
constantly upload stuff too.
Oh, I upload stuff all the time, shorts, da da. Like, they've really like pushed me in the closet, so to speak, like badly. Like, what the heck?
Yep. As soon as I stopped uploading regularly, I stopped getting subscribers. Like I get them trickled in now every once in a while from my live streams, but it's nothing like regular like it used to be.
Yeah, I can't understand it. I've been at 3,700, like I said, for like the last 6 months. It's crazy.
We've
Going
been
back,
hit by like 4 CMEs in the past few days. coronal
Oh,
mass ejections,
oh
and
yeah.
they're
There's
about to like strike Earth at any moment, and they don't know what to do because it's a compounded effect. They
yeah,
know the physics on when, you know, how they can protect the satellites and stuff like that when it's one, but when you have multiple, they don't know what's going to happen. So
yeah.
that's
Like I heard, the CMEs that are coming in, they're actually gonna disrupt the electromagnetic field of the planet.
mm-hmm,
It's actually gonna cause it to go out of whack. It's actually pretty big news. There's a couple of guys I follow that are, going crazy over this right now because, you know, our electromagnetic field is what protects us from, all the cosmic radiation and stuff like that. Not to mention that, all the satellites around the Earth, if you're on that affected side when it hits, you know, half of Elon Musk's satellites are going to come crashing down there. Oh, speaking of crashing down, I seen a friggin' meteorite come down. Was it last? No, 2 nights ago, and I'm going. First thing that came to my mind, hey, there's an Elon Musk satellite crashing back to Earth.
probably.
I wouldn't doubt it.
But you're gonna have very, very pretty auroras up there, like the
Yeah.
northern lights. Yeah, like they're gonna be really pretty.
It's been kind of cloudy here for like the last week, so hopefully it clears up this weekend. It's
Yeah.
starting to get a little bit warmer now, so yeah, spring is here finally. Thank God. Elijah, I guess we'll start with you. I seen you were working on a couple things this week.
Well, I've just been working a lot, so it's kind of I'm not necessarily working on things per se, but I am
Yeah.
buying parts to make a wind turbine. So I
Oh,
bought a 3-phase full bridge rectifier, and that's being shipped. I bought some fuses for my multimeter and stuff like that.
Yeah.
And just trying to get parts together. I bought the wind turbine and have the wiring and all the stuff for it, and so I'm gonna use that to basically charge my battery bank at night if I need to or whenever.
Do you have a lot of wind by your area? Is it usually
Where I
windy?
am now, there's a lot of trees, but I'm gonna be moving not very far from here into a more open area pretty soon, in like
Yeah.
the next month, and that's gonna be like an off-grid situation where I have access to
Yeah.
water, but that's
Right.
it. So I'm gonna make all my own power. And so I'm just trying to get something that can be utilized, during nighttime more, because I don't really have the setup to do a lot of like research like you're doing for more alternative power source. But
Yeah.
what would be really cool is like make your little power cell diodes and use it to power a Stanley Meyer water fuel injector that goes into a 2 horsepower like generator that makes 2 kilowatts of power. That would be
Yeah.
really rad, because I know he used like less than half an amp, and that's what your 10 cells are together are putting out. That would
Yeah.
be
Yeah, you don't need a
perfect,
lot
probably.
for the electrolysis process.
No. All you have to do, like Philip said, is heat the water up. So if you have an exhaust, say like in a car, I kept it in an area that had quite a bit of heat. So I noticed I was getting a huge amount of production of Brown's gas, right? And yeah, it really worked in my car. Like, mind you, this was like, ooh, how many years ago? 10, 15, 16 years ago. So yeah, it increased my fuel mileage by about 25-30%. So they work really well in diesel. I know a few guys that have worked with these quite a bit. So if you got a small diesel engine, they work really good in the diesel.
But I'm talking like straight up only water. That would be really cool.
Yeah. Yeah, yeah, that would be amazing if you could do that. But yeah, like I've seen a few guys. Well, the Joe cell thing, I watched probably every video that Joe put out, and this guy is crazy knowledge. What this guy knows. No wonder he hides in like South Australia somewhere in the friggin' outback, because the oil companies weren't too happy with him. And he also made a water purification system by just using magnets. Literally, he had a tube, had a bunch of magnets and a special arrangement. Swamp water through one end, drinking water came out the other end. No moving parts. It was all done by magnetism. Unbelievable. I couldn't believe what I was looking at. And he took the water from the pond, okay, musty, dirty, all that kind of stuff, put it through a pump, went through his device, came out the other end, got his glass, scooped up some water, and started drinking it.
So was there like sludge left in the process, or was it like transmutating it?
I don't know what the hell it was doing when it went through the magnetic field. It removed all the sludge, all the sediment, any bacteria that was in there was gone, because he was drinking the stuff right after it came out.
So was it just like distilled at that point?
I wouldn't say distilled. It just purified. Just
purified. So there was still probably minerals and stuff in there. Just
sure.
Interesting.
Probably minerals, trace minerals were probably still in it, but he took it out of a dirty swamp. I'm like, holy cow! Like,
that's pretty much mud water.
Pretty ballsy.
Yeah,
pretty ballsy. Like you.
Yeah, because there's a lot of different bacteria and stuff in there, parasites and my god.
Exactly. Yeah, he was drinking the stuff. Yeah, and he goes, "I've been drinking this stuff for the last year, and I never got sick."
But you know how useful that would be to so many people in like third world countries, and that's so important. If we know it's possible, though, we can try to attempt something like that, I think. Like
his shed was literally all these stainless steel and aluminum tubes, and they were all like not bored out, but they were all like what's the word I'm looking for? They were all very shiny, like
polished.
So yeah, polished and honed. And he said he had to tap them with a tuning fork, and he had to get the right frequency. If they didn't make the right frequency, they wouldn't work. So he had hundreds of these tubes all over his shed. I was like, holy man.
So again, he's tuning it like an instrument, like we see with different devices, like Malcolm Bendel.
Slipping over these magnets around them on the outside, so they look like speaker magnets, right? Mm-hmm. And he would lock them together in a certain arrangement, and then he was showing with the magnet paper what was happening with the field where it was getting canceled. So the water would go in, and since it hits that cancellation of field, it's like putting two north poles and forcing them together. And at that point, where I guess you would call it the blotch wall is, that's where the water now gets purified. So any toxic or whatever sludge stops right at that point, and only the clean water goes through. I don't know. It blew my mind what he was doing. And even like the Joe cell, like running his cars and stuff, his was running on 100% water. There was no fuel at all in his car. And we're talking engines.
He used like 4-inch, 3-inch, then 2-inch nested cylinders, just like Malcolm Bendel used 4, 3, 2-inch hemispheres or spheres.
Interesting.
Exactly.
And something about stainless steel 304 grade seems to have the right refractive optical properties for these types of processes.
Yeah, doesn't it need to be like shiny or like reflective?
Well, I think it's more than just reflective on the surface. I think it's the way the light scatters through the material itself, right? Because just like how you have Pink Floyd's Rainbow and the Prism. That's happening through every material, everywhere, every when. You just don't realize it because you only see a tiny portion of the spectrum, right? So I think there's
Right.
something about the way it's refracting and reflecting, because every change in density has that has a reflection also has a refraction, right? They're both goes on hand in hand. And I think it's like a dielectric field lens almost in the space in between, with the air being like an active plasma.
So is it like converting the light into mass? Or
I think I don't think necessarily that's the case. It has like momentum, and it has no rest mass like photons. If you want to call them photons, they don't have rest mass. But when you have phase conjugate waves, that's where the rest mass appears with the electron pair, right? So in theory, there could be phase conjugation going on since it's radially symmetric, right? And that could be what's like supercharging the aspect. So it's possible that that's happening, but I don't really know. Yeah. What I do know
so you
is
don't think
that
it's actually converting it to like energy, or like light to energy, or light to matter, or whatever?
I think that something about the way the crystal lattice is and the geometry combine to where it enables these processes to happen. That's really all I know. I think it has something to do with that.
There's no conversion between energy and mass because mass is all energy, and vice versa. And photons do have a mass because they do have energy. So I know Einstein doesn't like it, but it's very simple. If you have energy, you have mass. You can't cherry pick the equations.
Yeah.
Right, that's what I
Really.
was thinking. But I just, I don't know enough about this.
Well, yeah, like I said, photons have momentum, and energy equals time times c squared. So I don't dispute that.
That's pretty obvious.
Well, I guess what we can say is geometry and frequency are integral to these processes, and that's like a pattern that we're seeing. Like you said, the nested structures, the 432, and the different ratios, specific ratios. So those are different markers we can take, and I think we're seeing these patterns in a lot of different areas now. Now that Malcolm Bendel has released some of his work.
See, another one that's really intriguing too is heat engines. The Stirling engine. I think there's a lot of potential there, and there's some groups out there in Western Canada that are actually wanting to build at large scale and use the geothermal differential of heat. I think there's something there with that. I would honestly, if there were to be a company that came out that tried to attempt to create, using either geothermal to power Stirling engines, I would put money in it because I know it works. You know what I mean?
Yeah, heat pumps are objectively over unity. There's no disputing that.
As long as you have a differential, as long as there's a temperature variant between the two, you're always going to have power. Like these, there's ones you could buy right now. They'll actually sit on top of a cup. So you could put cold water in it or you could put hot water in it. This thing will constantly move. But if you put ambient, temperature water that matches, the ambient air, then it will stop. So it's either you put hot in it or you put cold in it. So, in Canada, we have temperature fluctuations like crazy here. You'd have a Stirling engine run like nonstop. Like it would just continue to run.
Think about it like this: every single wall could be like a Stirling engine type setup,
Sure.
and because you always have to control the climate indoors anyways, and then it gets cold
That's
outside.
right.
And the
That's
cold would
true.
actually drive the engine. And it's really good for constant RPM situations. Like you wouldn't want a Stirling engine for a car, but you would want a Stirling engine for constant power generation.
And yeah, because it can't be constant. It has to constantly be spinning. You're saying it can't like start and stop like an automotive vehicle would.
What I'm saying is that Stirling engines do not go with variable RPM. You don't really vary the RPM very much. It's like you're at that temperature gradient that you're working with, and
So
that's
you're
what
stuck at
sets
that
your
speed.
RPM. Exactly.
That's okay. That makes sense because you have an optimal zone for efficiency, and then in a vehicle you're going to need a variation of RPMs because you're going different speeds. But
Like
Right,
even
which
on
is
a
why you
car,
need to burn water.
right,
like on a car, here's a perfect example. You could use the heat from coming off the steel of the hood of the car. Like, you know how hot the hood of your car gets in the summertime? Well,
right.
there's a great energy source even right there. So you could have a little Stirling engine in the back of your car. Okay, say you had an electric car. So you put the Stirling engine and you hook up a plate on top of your hood of your car, and in the sunlight, that car is heating up like crazy. Runs your Stirling engine that could charge your batteries in the car. You know, there's an idea. I don't know.
Or even a thermoelectric generator cells all tied together, and then that could power an electric motor that could do variable RPM and high torque very well
I'm sure.
for a vehicle.
So, I know how many times I've burnt my hand or my arm on the side of the car in the summertime because it's so freaking hot. There's a really good energy source right there. Your car attracts a lot of heat, especially if it's black.
True. And the engine, if you're using a combustion engine, you already got all that waste heat. 2/3 of the energy is waste heat. So
Yeah.
I don't know why we don't utilize with hybrid vehicles thermoelectric generators underneath the hood where it gets hot from both the sun when it's not running to charge your batteries to keep them full, and
Yeah.
when it is
See,
running to, like from the motor. Like I don't get it, but
yes. Yeah, because like I know some of the new electrics. I think it's in the Chevy Equinox, if I'm not mistaken. They have a heat pump in it, and it'll take the heat and use it. That's generated either from the electric motor or the ambient air in the inside there, and pump it into the cab in the wintertime, so you'd have heat for the cab. So you could take the heat coming off the motor, because I imagine those electric motors heat up quite a bit. And yeah, they got a pretty interesting heat pump from what I've heard. So yeah,
yeah.
I like the Stirling engine in the trunk being powered by the sun that's heating up the outside of your car. And then your car's sitting, you drive to work, your car is sitting there in the sun all day long. You could have this freaking heat pump or Stirling engine running away, powering a small little generator that's charging your battery. So when you're ready to go home at the end of your shift, your car's fully charged. You didn't pay a cent for it. There's an
Right.
idea.
And it'd work at nighttime when it gets really cold too.
Exactly, because you got the temperature differential. As long as one side is different from the other, that engine's going to spin.
Right.
So, yeah, food for thought on that one.
Yeah, I've thought about that a lot, and I think the best application would be inside of a like part of a structure of a house, like
Here's one for
powering
you.
with some sort of generator and battery bank setup or something like that.
Yeah, here's one for you. You know what one guy did? He made a Stirling engine, and the part of the Stirling engine, the heat sink where you heat it up. What he did was he bought himself, those parabolic mirrors. So he focuses
Mhm.
sunlight parabolic mirror, the mirror reflects that high energy and heats up the tip of the Stirling engine. The thing just friggin' flies. Unbelievable. It's getting several hundred RPM out of it.
Yeah, but he would constantly have to like readjust it.
Well,
so it
no,
keeps on
yeah.
moving.
Okay, so you move a mirror. You know what I mean?
Yeah.
Like, who cares?
You could also use it to blind your enemies.
But the point is, you're utilizing the sun, you're amplifying it with a parabolic mirror, and you're heating up that tip of the Stirling engine to several hundred degrees. That Stirling engine's going to fly. It's going to put out a lot of power. And
Is there a way to harness that into a battery and then use
sure,
that?
you can charge
Because
batteries with it.
yeah,
Sure.
because that would be,
Yeah.
yeah.
Charge batteries, hook it directly up to a generator that runs, say, a water pump or something that you need, a utility. Sure.
You were saying
Ideas
something,
like that.
Elijah, you were saying something like a structure that's attached to the house. It would be nice to have one of those, what are they called? Like the water mills, like the water wheels. And if it's attached to the house, you could rotate that, and generate electricity with that, like on its own work.
Well, my thought is, like, if you're regulating the temperature of a structure anyways, and then outside is usually either hotter or colder all the time. Sorry, that's the dog in the background.
Yeah.
But if it's always hotter or colder in the background outside, then you have a differential of temperature in every wall of your house. So if you could integrate a Stirling engine in the wall itself with like a section of the wall actually being the engine and focus the energy on, like, let's say the south side of the house of that wall, if you're in the northern hemisphere, you would get all that radiant energy from the sun and really drive that thermal differential. And that could be like directly connected to batteries inside, because you want your batteries, tendered and also at a good temperature. So, and that way you have less wiring that way, because your whole battery bank and generator would be running inside and it's a relatively quiet process. And maybe that could be like connected to your garage area or your workshop area. It's my thought,
Yeah, there's so many things you can do with it because, the sun is there to, like, even in the winter time, I've got a sunburn in the winter. Like, it could be 10 below zero out, but if I'm sitting in the car and I'm driving and that sun's beaming through, the side and hitting me in the side of the face, I've actually got sunburns in the winter. So it doesn't matter if it's 20 below zero outside of your vehicle and I'm in the car, that sunlight's hitting me, I can still get burned. So the sun is something you can utilize at all times of the year, all seasons. It doesn't matter. It's just a matter of creating the differential inside the car, outside the car, inside the house, outside the house. As long as there's that difference, you have energy. And that can be utilized into a Stirling engine.
You probably get sunburned because of the snow. Everything is white. It reflects more energy. There's nothing absorbing that heat.
Yeah, I've been snowboarding many times, and I wear the big glasses, and at the end of the day, it looks like I got like the raccoon eyes because I got burnt. All my cheeks are all red and everything. Oh yeah, just a reflection right off the snow.
Here's another idea. You know that when you dig into the ground, at some point it's pretty constant temperature. And on the surface, it varies temperature very widely. So you could, in theory, vertically orient a Stirling engine that's buried in the ground to where one side is like approaching the thermal equilibrium of around 50 degrees Fahrenheit, or 52, or say 52 approximately, once you get around like 6 feet in depth, right? But then when you go up, depending on which climate you're in, it'll have a gradient all year round. Doesn't matter which climate you're in.
Yeah. Yeah.
But where you are will dictate what type of gradient it'll have. So that'll always output energy if you could install the infrastructure.
Yeah. Elijah, I don't know. Do you know Laser Saber on YouTube?
Yeah, I watch him.
Yeah. Okay. So he made this device a while ago. Everybody could check it out after the show. He made this aerogel container. Excuse me. And he put one of those, um, I guess, Peltier. I think it's Peltier converter. Excuse me. And he was able to get that temperature differential and it powered a small, LED for like days.
That's pretty cool. I've seen
Yeah.
him also do something that was even more impressive, where he had like um, basically a magnesium ribbon that he basically had that some wet paper towel and like an I think it was an activated carbon cylinder or something like that. And he took the cylinder and he wrapped it with the paper towel and then spiraled the ribbon around
Yeah.
the entire
I've done
cylinder.
many of those. I've done many of
And
those. They work really, really good. But
yeah,
problem is that um, uh, the way he was doing it, the magnesium eventually would deteriorate. Bendini actually came up with a method of protecting the magnesium by using alum. It's a preservative used in cooking. And if you mix
yeah.
up this alum and you put it over top of the magnesium will last for a very, very long time.
So Rochelle salt is actually ferroelectric with a high epsilon sub R constant, similar to barium titanate. And so you're getting spontaneous polarization out of it.
How about memory metal, the one that like goes back to its original shape if it's with temperature, with like hotter temperature with colder temperature, it relaxes. If you're talking about there's an equilibrium, if you put that memory metal, couldn't it oscillate back and forth, back up and down, and generate electricity that way, just from the ground temperature?
Like piezoelectric metal or something like that.
There's memory metal, like those are like with heat they retain back their shape, and with cold they release, they get deformed. And so if there's an equilibrium, whenever it dips
It's
down, it
called
gets cold,
the
and then
metal you're talking about is called nitinol.
nitinol. Okay, that's right, nitinol. Yeah,
It's
something
made out
like
of
that.
titanium and nickel as an alloy.
Yeah, it's mixed together. Yep. They were experimenting with the nitinol engines back in the 70s, and they were producing kilowatts of power. Where is it? Where is it? Why didn't it come out? Like it worked. It was a viable method of creating electricity. Where is it? So here we go again, right? And they've done quite a few millions of dollars into it. So it's real technology, but again, got freaking buried.
So how do you think they were outputting that much energy with nitinol? Do you think they were making a spring sort of setup that would get
Yeah,
deformed being pulled and then pulled back, or what?
they made it almost like a combustion engine with like a crankshaft, and they had, I believe, there was like 3 or 4 levels of this with the springs, and they were passing the hot water over it, and as it went through each level, it went from up and down in temperature and created the back and forth pumping action that turned a crankshaft, and it worked. Like there were several designs on the method of using nitinol in an efficient way. Uh, the point is, it worked, and it worked actually a lot better than they thought. And yeah, it got buried. It got buried. It's like, come on, like this stuff should be out there, you know. And you can buy nitinol. You can find it anywhere online. You just type in nitinol and go and you can probably get it on friggin' Amazon for crying out loud. You know, it's not like it's a banned substance or nuclear material that you can't get your hands on. It's out there. I've seen people make small nitinol engines. So it's a matter of engineering the right apparatus to run it and then circulate the water.
So instead of having to input energy on the crankshaft of an electric generator to separate the dipole, how would one separate the dipole inside the generator to be a self-running generator, electrical generator? Then you can bypass all the trying to get the special metal or utilizing heat or utilizing the sun. You could literally live in a cave and have no sunlight and be generating electricity at that point. And I think that's kind of the direction we need to go, is make a self-running generator that's basically separating the dipole on its own and transducing the time domain into energy, not just as E equals mc squared, but E equals tc squared.
Well, I think that's kind of the direction my power cells are going in, because technically I don't have to charge these at all, right? I just been doing tests, every kind of test you can imagine on it, putting in extreme cold, putting in hot. Like I've run these cells at minus 22 degrees, and they still run. And I didn't charge them, nothing. I basically slapped them together, took them outside. They produce power. It doesn't matter. It could be hot.
That's great,
cold,
because
whatever.
usually batteries, like cold kills batteries.
Right. It doesn't kill my battery. Now I've perfected the solid state electrolyte in it. I have no issues with heat or cold. It's like a lithium battery. I was watching some tests they were doing. Stress tests. As soon as a lithium battery hits 100 degrees C, poof, it
Yeah,
explodes.
it's very unstable.
Mine is just one below on the periodic table of lithium. There's magnesium, and before this thing will catch fire, it has to reach 900 degrees C. That's the flash point of magnesium. So if you're planning to throw your battery into a fire pit, be my guest. But you know what I mean? Like it will run away at 900 degrees unless it's in a bad situation. Any battery is going to blow up.
That's like 800 degrees difference in safety.
Yeah, pretty much.
Yeah, that's a lot. Yeah.
So it's like, if you want to throw your battery into a fire pit, be my guest. But, we're not going to do that. You know what I mean? So safety aspect of using magnesium is great too, right? That's another big bonus.
So, Mike, where do you see yourself going with these power cells and diodes? Are you going to sell them as kits on their own, or use them as a component in something that amplifies energy, or use it in Stanley Meyer technology, or what do you want to do with it?
I could sell the battery as an OEM, like actually build cells. And you could buy them like you would a battery, from the store. Or if you need it for a device or an application somebody's looking for, I can make something that would meet the requirements of powering that device and put it into a box and whatever, and make it as like a power cube or whatever. So now that I've got my sealing device, now I can seal my cells up so they'll last way longer. And so I'm at that point where I'm pretty happy with the solid state electrolyte I've developed, and I think it's a winner. And I doing a shelf test right now where I just give it a 10-second charge, take a charge measurement at that time, and then I'm going to leave it for a couple of weeks on the shelf. And the big battery companies, they do the same thing. see how much a voltage drop will happen in the battery over a 2 week span just sitting on the shelf. And Cat L in China, they do it all the time. They'll take a new battery, put a charge on it, take a measurement, throw it on the shelf for 2 weeks. Come back in 2 weeks, take a measurement, see what the difference is. So their cells are retaining about 85 to 90%, sometimes 98% of their charge just by sitting on the shelf for 2 weeks, doing nothing. So they call it a standing voltage charge test. So these things are holding the charge. It's pretty impressive. They're holding about 90% from what I see right now. So.
And that's the diodes or the big cells that are square and flat?
The big cells. The big cells. Like these small diodes, like these lost probably maybe a little bit more because there's so little of reactive metal in it. Also, the surface area is very, very tiny compared to my big cells. So it's about 20% drop in these, but I got a few cells here from last week and they still have the same charge they did a week ago. So, sometimes you'll get one really good cell and then you'll get another cell that just doesn't really perform as good as the other ones for whatever reason, some inconsistency in the build or whatever. But that's common. That's why, when you're doing homebrew type batteries, you're going to get the odd cell that's not going to perform very good. And then you're going to get other cells that are going to be working really well, right? So it's kind of a process of elimination as you're building them. Put the good ones on one side and the ones that need help on the other side, and hopefully you could come up with some way of getting those cells up to par, afterwards. So it's a lot of experimentation. I've been working on these cells for over 2 years. I've done pretty much everything and anything you could do with a cell, like just stuff, magnesium air batteries, aluminum air I've done everything. So I'm at a point now where I can make this into an actual product, but obviously money is always the big issue, right? It's getting an investor or whatever that's interested in it. I even got a company name that I'd like to use. So.
What is it?
A company name? Velocity MG.
I think you should go for it. Form an LLC, and even without investors, with what you have built, just start stacking cells to where you make your 12-volt battery essentially out of it.
Yeah.
And then figure out a good price that you feel is good, and see if your community starts buying it. I would want one. I would want to buy a few. I want to make my own as well.
There's no LLC in Canada, so you'll have to incorporate.
Yeah, it'd be an incorporation, but you know what? Even trademarking would be another one too. I could trademark some of this stuff. Like the electrolyte itself right now, I have to keep that real secret because, I'm competing with some other companies out there that are claiming that they have a real good solid state electrolyte, and I don't want them to know what I'm doing. Like Donut, that company out there right now, Donut, that has supposedly this super solid state battery. They won't even tell you what the anode is.
Maybe
they won't tell you nothing about the battery. They're keeping it so secret.
Maybe you can use once I'm settled. Maybe you can use my company to bridge, to talk to Lockheed Martin and so on, because you need to be incorporated in the United States to talk to them. And maybe I can help you with that once I'm settled.
Yeah. Oh, did I tell you guys, the guy who really got me into these power cells was Michael Kans from Quantum Power Cells. He had a really popular YouTube channel, and then he died in 2021. And everything he had just basically vanished. Well, about 2 months, about a month ago, the guy contacts me and he goes, "By the way, I grew up with Michael Kantz." I'm like, "You gotta be freaking kidding me." He goes, "Yeah, I was his next door neighbor." So we started talking. He lives, where's he live? He's in the Midwest somewhere. I can't remember where he was. Virginia. No, Arkansas. He lives in Arkansas. But he grew up in Florida where Michael Kantz was at the time. He still actually knows Michael Kantz's sister. So it turned out Michael Kantz was building these cells and then he dies, right? And I said, first thing out of my mouth was, where did Michael Kantz work? He goes, Bell Labs. I'm like, oh God, are you serious? Of course he was making this stuff. He worked at Bell Laboratories. He was the senior engineer at Bell Labs. I'm like, oh God, okay. Now I know what I was dealing with, right? These guys have a huge, massive budget, like technology there, it's like crazy, you know? So, yeah, he gave me quite a bit of information. There's some stuff that he made, his cells. Some of them are still out there. Some people have them. And I asked him, I go, do you ever find out what he was using in his cells? And he goes, no, he kept that right to his heart. He wouldn't let that go. So, yeah, interesting story on that guy. And as soon as I heard he worked for Bell Labs, I'm like, oh my God, really? It was surprising, but I wasn't surprised because he seemed to be quite a bit further ahead than everybody else. See, he developed that silicon carbide cathode. So he had this supposed black gel that was in between the two plates, but he never disclosed what his anode was. He said he never used magnesium, but in some of his experiments in the past that I managed to find the videos on, he was using magnesium. So
there's another mineral that the U.S. military wants in Canada. I forgot the name. It's in the Maritimes. There's a specific material that is
cesium. Cesium.
You think so? Yeah, maybe that's it.
Yeah, cesium's really high on the periodic table. Cesium, yeah. I think, is number one as reactive metal. It's extremely dangerous.
Oh, yeah.
Can we say boom? I seen these guys on YouTube. They got a hold of calcium metal, like 100% calcium metal. They threw the freaking. It was like a block, about 4 inches by 4 inch block. The guy throws it into a pond. Boom! The thing launches in the air, comes down, hits the water again. Boom! Explodes again, flies like 20 feet in the air. I'm like, oh my God. It's probably still on YouTube now. It was hilarious. It just showed you how reactive calcium was. It was actually explosive. So like cesium, yeah, cesium's cesium, potassium, they're highly, highly reactive, dangerous reactive with water.
I saw something today. Like if you rusty metal, if you smash it against aluminum, it creates a spark. Yeah. It could it's the way they form thorium. Wouldn't that be useful in generating energy? I mean, we're talking a heat to the point where it melts, it becomes like magma, becomes, liquid metal.
Just trying to think how you would do that. Well, when something's rusting or corroding, that's the way a battery works, right? It's based on corrosion using a reactive metal. So it could be aluminum, it could be lead or whatever. As soon as it's exposed to an acid, then you have rapid corrosion, right? And the corrosion is rust, right? And that's releasing electron flow, ion flow. And that's how your standard battery works, right? And galvanic redox reactions, right? So I've with the electrolyte that I've manufactured, I've created the conditions for magnesium where the initial contact of the magnesium plate with the solid state electrolyte creates that passivation layer or the SEI interface. And the SEI interface is everything because when it creates a very thin layer of oxidation, when that solid state electrolyte hits the reactive metal, it'll give an oxidation layer. And when it creates it, they call it passivation layer. So when it creates that passivation layer, now it's got like a protective coating of oxide on it. So, and if you do it just right, that oxide layer won't get any bigger because it's solid state. There's no water. Water kills the battery or kills any cell or the reactive metal. The water is the enemy in my cell. If I got water in my cell, it'll destroy it. So I have a way of extracting all the water out of my electrolyte, pull it out. And I use that sodium polyacrylate. It pulls all the water out of my electrolyte. So when it's ready to go, that electrolyte feels like the best way I could describe like clay, like DAS clay. And you pat it on the ground and you make it nice and flat. Well, that's basically what my electrolyte feels like. It's like clay, but it's dry. There's no water in it. And because of that, that's why my magnesium doesn't deteriorate. It'll create a passivation layer. It'll make a little oxide layer on it. But after that, that's it. It's done. It's got that protective coating.
Oh, and, by the way, so something smells like Bernie, tastes like Bernie. So Bernie must be around.
Oh, Bernie's here. Yeah, I seen him in the chat there. I'm just gonna scoot up for a quick smoke, guys. You guys can chat it up. I'll be right back.
Is Bernie back in Canada or is he still?
No, he's in. I think he's in LA.
Yeah, he's in LA right now.
Yeah. Okay, I'll be back. Yeah, he's good. He said he's gonna come on in about 5 minutes. I'm just gonna scoot out real quick. I'll be right back.
You're in LA too, right?
Phil?
Yeah, I'm at Culver City. Bernie is somewhere in LA. I don't know where, but somewhere. But it would be cool if we could meet in Santa Monica or something like that. So
and Gerald's here too now.
Gerald, yeah. There he is. Yeah, let's meet up this weekend, Bernie. I'm gonna train tomorrow morning, and we can meet after. Let's go in Santa Monica and get wasted. No, I'm just kidding. Let's go somewhere. Let's figure it out.
Was that valuable metal that you were talking about, Phil, earlier, possibly gadolinium instead of cesium? Maybe?
Yeah, I don't remember. Let me check it out. Give me 1 sec.
My thinking is, if you can get like relic neutrinos to form solitons, then you can use that as energy or something like that. I don't know the exact process, but it's talked about on the Martin Fleischmann Memorial Project. And that would be a more non-destructive process to get energy than trying to have some sort of redox reaction.
I think it's cobalt and graphite supply chain. No, not this one. Sorry, wrong one.
Cobalt 60 is interesting because of its radioactivity. It's kind of radioactive, so it could be used for energy, and also it's used to make water from sunlight out of hydrogen. So if you're flying through space, and there's an average of 3 protium per meter cubed, out there in
Yeah.
outer space, your spacecraft could actually be harvesting and generating water through a sunlight cobalt interface, and then you could use the water for fuel through a Stanley Meyer
Okay.
fuel injector into a rocket sort of setup. But better than that is you would have an alien reproduction vehicle that would be basically taking that protium and converting it into a non-nuclear quantum spin 2 state. So it would be going into deuterium or tritium, into helium, and so on and so forth, like that. And you could actually be getting energy as you fly, and so the faster you fly, the more energy you could get.
Okay. By the way, the mineral is graphite. Actually, not only it's graphite, but it's from my hometown. For crying out loud, it's from my hometown. County. So, man, my own county could be pretty rich right now if the idiots could start selling the mineral. Yeah, I said I posted the link. I posted the link in the private chat. Um,
Sweet, thank you.
yeah,
Graphite's super handy because it acts like as a little penning trap with the torsion field. So similar to how Ben's rodent coil spins a ball in the center, it'll
okay,
actually do that with a particle that gets trapped in the center of that hexagonal structure, because each corner of the hexagon is a magnetic loop, and they all form together to be like a big giant hourglass shape that goes into a magnetohydrodynamic, flow state, right? So
okay,
it's both an LC circuit, a torsion field tap, and it's also like basically this conductive interface that conducts electricity through its labs, all in one.
is it? Yeah, I can. Is it like a diamagnetic or something like that? Or
I don't think it's diamagnetic, be, because it's each carbon molecule or each carbon atom has a quadrature bonding structure, right? And so that taps the imploding scalar field really well, and that would
yeah,
actually be interacting with the orbitals, making it not diamagnetic. Because if it's interacting with that orbital structure and it's not resisting changes to its magnetism with nuclear magnetic resonance, that wouldn't make it diamagnetic.
oh, okay. By the way, Mike, I just put like I was saying to Elia, I posted a link in the private chat where the U.S. military wants graphite, and graphite is from my hometown county.
Yeah.
Uh,
We got a lot of
you know
graphite
what?
actually not too far from where I live in Coalburg, Ontario.
Yeah, there's like 100,000 tons of
Oh
graphite
yeah,
in
huge,
Outaouais.
huge. Yeah, yeah. There's one a big plant in Coalburg, Ontario. It's in between Toronto and Kingston.
Yeah,
There's a big refinery out there. Yeah.
yeah.
You
So
can
yeah,
use it for
maybe
stealth for
Sorry.
the aircraft. Graphite, you can use it in the paint for stealth aircraft, for anything that needs to be protected
Actually, know what?
from radar signatures, like drones or
Actually,
whatever.
know what I found that they use for
Yeah,
radar? Charcoal.
charcoal. Right.
It's charcoal.
Activated carbon,
Yeah,
graphite.
yeah. Gerald's in the chat tonight. I wish Gerald would come on. That would be nice.
yeah. What's cracking with Gerald?
Yeah, I don't know, man. He's the mystery man. Haven't talked to him in months. Yeah. I give Gerald a link every time we do a show, so is more than welcome to show up.
Yeah, maybe you can post the link I posted in the private chat, in the public chat.
What?
Very interesting. The Guardian link. Yeah, I posted a link, theguardian.com.
I'll take a look at that.
But I forwarded it in the public chat. It's very interesting.
Okay, here I'll copy it and then I'll put it in the chat here. Okay, there you go. There's the link.
Nice.
Yeah, cool. So yeah, like graphite is a huge thing. Like I'm using carbon graphite plates. Actually, I've been experimenting. I bought here. Hold on. Got the graphite plates that they use in nuclear reactors. A friend of mine had access to the guy who supplies all the CANDU reactors in Ontario with the graphite plates to, it's a heat exchanger, right? Well, I wanted to experiment with something a little thinner than that. So I actually, on Amazon, I purchased the graphite foil. It's bendable. It's bendable to a point, but I was making some cells with this and it works really, really good. So it's basically the same material as my other plates, but they're a lot thicker. So you'll get quicker response times with the charges, but when it comes to charge density, it's less because it's thinner, right? It's not as thick. But regardless, I've worked with this and I'm getting some good results. So you can buy this stuff on Amazon. It's basically the same stuff I have, but I got it thicker, a lot thicker. So just thought I'd show that. Just look at the chat. Gerald in his teeth.
Where did Bernie go?
Well, I know he's in LA. He was doing the show with Nathan earlier. He said he was going to jump on there sooner or later.
Yeah. He got the right to do one call, so he's gonna call us. When you go in jail, you have the right to do one call.
Yeah. Yeah, really. Instead of calling his lawyer, he calls for the
Mike, have you looked into Garrett Modell's 0-point energy researcher or my advanced composite stacks, the PowerPoints?
Say that again. The first guy's name?
Garrett Modell.
Garrett Modell. That rings a bell. Garrett
Modell. I think you could draw some inspiration from that or my my advanced composite stack presentations. I have like PowerPoints and a bunch of slides on it that I can send you. I also posted on Facebook and LinkedIn a long time ago, but I deleted the LinkedIn. So
I'm trying to do a Google search on them. Can we harvest 0-point energy with Garrett Modell? Okay, I found a link here for his it's a 52-minute YouTube video with him. I'm going to leave that here. I'm going to actually, maybe I can, I'll leave that here and then I can post a link for it.
He makes what he calls a mime cavity, which is really just an asymmetrical light cavity. And he's getting basically this tunneling phenomena, electron tunneling between an anode and a cathode. And that it's a nonlinear oscillating charge, and the tunneling probability goes up with a higher voltage, smaller band gap, and higher frequency, right? Because that couples with the smaller.
So wouldn't that be similar to what I'm doing in a way?
Exactly. So basically, yours is very symmetrical, but you have materials that are asymmetrical, and I'm not going to talk about your dielectric in the middle, uh,
Yeah.
but I believe that's your asymmetry with the bonds moving around. And
That's why I was-
basically, what he's doing that's different is he'll have like silicon oxide, nickel, silicon oxide, some other metal, like he used palladium because it worked good, even though it's really rare. But you could use like anything with a different EV value.
Yeah.
And then he'll have like um, a thin silicon dioxide layer, I think, or maybe it's just a thick glass layer after that. I forget exactly. But
Yeah.
when you have that thick glass layer with
Yeah.
followed by an aluminum plate, you
Right.
get basically an asymmetrical light cavity that drives the charge from one metal to the other metal.
Yeah. Now, here's an idea that just kind of popped in my mind. I don't know how. Uh, if you take the magnesium plate and you put a thin layer of gold leaf, 24 karat gold leaf, and then put the solid state electrolyte, you think I would get some action going there?
Like in your cells, not your diodes.
Yeah, in the cells. So I take the magnesium plate and then I actually have 24 karat gold leaf and place that right on top of the magnesium plate and then put the solid state electrolyte on that.
I think you would actually want to have a different material like silicon dioxide in between the magnesium and the gold so that you're separating the EV values and increasing the electrostatic potential while allowing chiral flow in between, and then make your asymmetrical light cavity with like glass and aluminum. And then that would drive the charges to tunnel through the silicon dioxide, especially
Yeah.
if you applied pressure.
How
But I
about
think if you put the two metals right on top of each other, they'd kind of have the electrons want to conduct really well through the gold, but magnesium's also conductive, right? So
right?
they start to become a sea of electrons together, and so that difference of electron value wouldn't be as
It went,
readily utilized unless you have
yeah.
something that's dielectric in between them that
Okay.
also allows chiral flow.
How about barium titanate?
Barium titanate will help your spontaneous polarization to keep your charge.
Yeah.
So it's going to be like it'll work really well with your dielectric, with what I believe it is,
Yeah.
because of the bond angles being so loose in your dielectric, that barium titanate is going to facilitate the bond angles and the magnetic moment of oxygen to polarize.
Right. Mhm.
So you could use that as basically a phase conjugate mirror, possibly, instead of the aluminum. So to replace that aluminum plate, like I was saying, with the asymmetrical light cavity, put barium titanate there, and now maybe you have a phase conjugate mirror. Now you're utilizing the time domain transduction. Especially if you get the stack to be thicker, but you get the band gaps of like the in between your two metals to be really small. But if you can get the overall stack to be thick, you would be tapping high frequency with the low frequency. And if you can stack those harmonics, it'll work good. Because like your low frequency is your radio waves, which has more energy overall, but your high frequency is high spatial energy, but it's less energy overall with that type of light. So it's like concentrating the energy differential across the metals, but then you're tapping it overall with like a stack that's like bigger.
Right. That's not easy.
It's not easy, no, and that's why I don't think it's been done besides like in very specialty, like DOE settings. But I think it's something that's commercially available, needs to be like put out into the public, that works good enough, like what you're doing. And I know it can be made better. I just don't know exactly how, because I haven't done it. But I think that you can do it, and I think that like Garrett Modell and like, you know, other things might provide good insight.
Yeah. Yeah. Well, I'm definitely going to check them out for sure after the show. I'm going to watch that video. 52 minutes long, so I imagine there's some useful information in that one.
Yeah, he's got some longer videos too, and Tom Bearden talks about phase conjugate mirrors, and I think that's where the spontaneous polarization property can be really utilized well.
Yeah. It's just like creating the proper conditions for the flow of energy from the anode to the cathode. And if you get it just right, you don't need like a catalyst or like acid or, you know, an alkaline environment. It'll just flow.
It's like the electrons just appear there because the frequency superposition makes it happen.
And that's what my electrolyte's doing right now, because it's 100% alkaline. There's nothing there to acidic, because I'm not getting any dendrites. As soon as I get it sealed up in the sealed bag, there'll be no corrosion whatsoever. It'll stop. And I might actually put some sodium polyacrylate in the bag with it, so if there is any moisture, it's going to soak it up and hold it and keep it in a safe spot where it won't affect the cell.
It doesn't give off heat, right?
No heat at all.
It'll be endothermic, actually. It absorbs heat like an endothermic reaction.
Yeah, and that's why, the anode, the cathode on mine tends to cool down a degree or two. So, showing that, there's no heat. It's actually cooling down.
See, that's another safety feature, like the higher temperature, like for safety wise, and then, it doesn't give off any type of heat.
And the other thing too is what's different about my power cells than any other commercially made cell right now is they need a separator in it. My cell does not have a separator. It's plate, solid state electrolyte, plate, done. There's no separator. And I think that's also an advantage too. Now, I actually do have separator material that they use in lithium ion batteries, but the way I've engineered this, I don't need a separator. And the one cell, I did internal resistance of the cell test. It's only 2.4 ohms. That's it. The meter would beep almost right away and shows only 2.4 ohms resistance. For battery internal resistance, that's actually really, really good.
I know you tried some in series. Did you try like 5 in series?
Yeah. Oh, yeah.
Did that perform better or worse compared to like 3 or 10, or did you compare like how many in series?
Yeah, like you get more, say like you got 2 cells, you hook them up in parallel, and then you would do like groups of 2. So you'd have say 10 or 12 cells, but you group them in 2s in parallel, and then you go in series to multiply the current. Right?
Right.
So, or sorry,
you're doing like 5 in series with 2 groups of 5 in parallel, or?
Yeah, you could go like that. Yeah. I usually try to get 2 cells grouped together in parallel, and then do several stacks like that. And then when you hook up all those separate stacks, hook them up in series. So like a parallel series circuit.
that makes me think if you put inductors in, like if you had a row of capacitors and another row of capacitors, and you have inductors in between the nodes of the capacitors, you create this like mesh almost that like can amplify the energy output. Maybe your diodes could be configured like that with like little antennas that are like rectifying the time domain. With you could even have difference in sizes between all these coils, right? And that could be like different velocity factors, right? Just like what Joel was talking about.
Right. And the other one too is I've got a lot of diodes. So when I make these groups of cells in the diodes, would separate each, actually make the series circuit. So you're not getting a backlog of power. It's constant flow in one direction. So I got Schottky diodes. I got N4007, N4006, and I think about 3 different varieties of Schottky diodes. So I'll experiment with all those, hooking up the circuits. So I would say I would probably I even bought I think 6 small 1 farad 3 volt capacitors, super caps. So they seem to fill those up, no problem. So I could put those in between each circuit to build up capacitance in that circuit as well. And each one of those capacitors, 1 farad. That's 4.5 joules of energy. So,
hey Bernie, where are you at? Are you in Compton or what?
I am in LA for sure. You're still in LA, brother?
Yeah, I'm in Culver City. Like I was saying, I'm in the coffee shop. I'm about to get kicked out now, but yeah, let's meet in Santa Monica or something like that tomorrow.
Okay, I'm supposed to go to the LAX. There's like the hotel there or whatnot. There's the Alien Event Conference.
Oh yeah?
Yeah, if you're interested in joining for that, maybe meet up first and then go down together.
Yeah, well, I'm gonna train tomorrow morning and then we can check it out.
Yeah, for sure. Message me. Give me.
Yeah, let's make some noise over there.
That's my whole point on going is just to call out the frauds and be like, "Oh, here's some real technology that's actually going on."
Yeah, let's tell them. Tell them what to do. You know.
Right.
Mr. Gerald's in the chat tonight.
I seen that. Doing well.
I think he's shy to show up. You know, he's a little bit shy, Gerald. He needs to unshy himself.
Unshy himself. Yeah.
That's funny.
Yeah, he hasn't been on it in a while since last year.
So I just did a little research and found out that I definitely can't be experimenting while in California, as it's actually I will get a massive fine and potentially arrested because it's illegal to work with even just aluminum and salt, let alone adding electricity.
Yeah, you're supposed to be in vacation. You cannot work while you're in vacation. So the laws are very strict, you know. Me, I can work because I am on a B1 visa, so it's different.
I need one of those.
Yeah.
We'll talk about that tomorrow.
Yeah, sounds good. So yeah, I'll check it out. I'm about to get kicked out of the coffee shop, but I'll send you a message. Let's chat tomorrow.
Sounds good, brother. I look forward to seeing you.
Sounds good. All right.
Yeah, we got about another 5 minutes. I guess we'll just finish up our conversations here. Don't forget, we go live to air again next Friday at 9 o'clock Eastern, 6 o'clock Pacific. And if you haven't become a member of the Faraday Research YouTube channel, I got over 1,000 videos and probably thousands of hours of live streams. You can, it's $3.99 a month, and you're getting access to all this stuff, I think it's a good buy. Um, don't
I,
forget to
I I invited Toby from Montreal for next week, so that's gonna be interesting.
okay, that'd
He's
be good. Yep,
very knowledgeable as well.
yep, that's cool. We always enjoy to have new people on. And oh, Bernie, while you're down there, you should try to get a hold of Vernon Roth. Maybe try to get him back on again.
Absolutely. I'll give him a shout here tomorrow and see if we can have him scheduled for next week as well.
Yeah, that'd be great. Yeah, he's cool. I like Vernon Roth.
Oh, Vernon is a generational wealth of information and experience with his grandfather, his father, and him all working between hydrogen, free energy, and anti gravity. It's treasure trove.
Yeah.
Yeah.
And then probably after that, we should try to get Dr. Yu on again. And
Absolutely, and Robert Morningstar as well. He does a lot. Talk to you.
yeah, that sounds good.
All right, brothers and sisters, I'm out. So see you
All
guys
right.
next week.
Yeah, thanks, Phil.
God bless.
Bye.
See you tomorrow.
Cheers.
Yeah, see you, Phil. Yeah, definitely. That was a good show. We had some good information. Elijah is one guy I like to talk to.
I was just
Chat a lot. So he's helped me out quite a bit with the cell because like half the time I'm like, what the hell? What the heck's going on? So
Yeah, I
got
like
Bernie,
just
I got
talking about
Elijah.
it. It's cool that you reached out, and anything that I can do to help, I definitely want to. Like,
Yeah,
I want to even physically make stuff and like get it to the point where people have access to this sort of technology, whether
well,
it's
that's why I like
hydrogen
to.
fusion or whatever.
Yeah, like
There's
when I get some of these cells built and I like what I have, I'm going to send you a few of them, and then you can play around with it and see what's going on. It's one thing to talk about it, but to actually have it in your hands,
Mike, I want some before August 12th because I'm one of the believers that, we're going to lose gravity. So I need a couple of these just in case,
I think you're going to be just fine, Lulu. I don't think
Oh,
you're gonna
it makes sense to me. I've listened to so many videos about it. It makes sense. And just let's pretend it's going to happen and prepare for it just in case,
prepare for the
Oh,
worst, hope for the best.
Yeah, I mean,
okay,
at the end of
so
the day, we get to keep all the cool gadgets if it doesn't happen, but let's prepare
okay,
it as if it's going to happen.
yeah. Well,
Yeah.
Gerald says he's going to be here next weekend, so that sounds good. So
Amazing.
hopefully we'll have
Awesome to have Gerald back on.
yeah, he has some explaining to do. He hasn't been on it in a while. Yeah. So I guess we're gonna square up for the night. Everybody, thanks a lot for tuning in. We go live to air again next Friday at 9 o'clock Eastern, 6 o'clock Pacific. Elijah, thank you very much for coming on. Lulu, thank you. Philip, he's already gone. Bernie, we'll chat soon. And everybody have a great weekend.
God bless and happy spring equinox, everyone.
Yeah, exactly. All right, guys, take care.